addition and subtraction of complex number. So we'll see the sum and the difference of two complex numbers. Alright, so let's move on. Let's see some examples here. But before we go to addition and subtraction of complex number, we have to discuss its representation. So complex number is represented by either C, and you have to double it, and or Z. But for simplicity, we have to just let's use just Z, simple Z. But this is the representation of complex number. So complex number, let Z is a complex number, okay, and it's represented by, let it be A plus BI, or you can also say it like X plus YI, okay. So in this case, we have two parts. The real part here, real part of complex number, and the imaginary part. All right, so we have the imaginary part here. This is imaginary part of Z, and real part of Z. So if I give you, for example, Z is equals to 3 minus 2i, so the real part of Z is 3, and the imaginary part of Z is minus 2. Okay, so you don't have to include I here when you are mentioning the imaginary part. Just the coefficient or the number in front of I can be just the answer. So let's move on to the addition and subtraction of complex number. So if I give you two complex number, let it be Z1 is equals to minus 6 plus 3i, and Z2 is equals to let it be 9 minus 4i. So I want you to figure out or to find the sum and the difference of these two complex number, Z1 minus Z2. Pause the video and try. Okay, so when you're working on the sum of complex number, any complex number, it's just exactly the same as adding real number. Just the real number situation comes here. When you're working on real number here, and under the real number, for example, if I give you x plus 2, and if you're asked to add with x minus 5, for example, you just add only like terms, right? Do the same thing for complex number. You are going to add here, you have x plus x is to x, and then you have to add 2 and minus 5, which is minus 3. Do the same thing here. Add real number with real number, imaginary number with imaginary number. Therefore, accordingly, this goes to minus 6 plus 9, all right, plus 3i plus minus 4i. So this is the same as 3, okay, and 3 minus 4 is minus I here. So this is the answer for the first one. So for the second one, again, you can apply the same principle as you are applying for real number, because complex number is a real number, I mean just a number, one of the number. So do the same thing here. So minus Z1 is minus 6, okay, plus 3i. So minus 9 minus 4i. Okay, so I want you, or you have to distribute first here negatives. So first, let's 6 plus 3i. So when you distribute this negative, so it goes to negative 1 times 9 is negative 9, and negative 1 times negative 4 is positive 4i. Okay, so this goes to, you can combine like terms, so you have to work with this one. This is negative 15, and then again you have to move to the I part, the imaginary part. That goes to 7i. So this will be the answer for the difference of the two complex number. Sometimes you would be asked, like, if Z1 is equals to, for example, 13 minus the square root of 8. Okay, what's the answer for this one? The square root of minus 8. And then z2 is equals to, let it be 5 plus the square root of negative 16. Okay, so pause the video and try by yourself first. Okay, so let's solve this one. The first thing that we need to do is you have to change this imaginary part, this the square root of negative 8, to the I form. Therefore, this is the same as 13 minus the square root of negative 8 means the square root of minus 1 times the square root of 8. Okay, so this is again the same as the square root of 8 is just simply you can put is as 2 times 4. So the square root of 4 is 2. 2 will be out, so 2 will be there. So this is the same as 13 minus the square root of minus 1 is I, and the square root of 8 is 2 root 2. 2 root 2I. Okay, let's do the second one as well. So the same is true here. So 5 plus, okay, 5 plus 5 plus the square root of negative 16 is the same as negative 1 times the square root of 16, and the square root of 16, as you know, is just 4. So this is the same as 5 plus 4i. Okay, so I want you now to find the difference, the sum and the difference, z1 plus z2 and z1 minus z2. All right, so just directly solve this problem. So you have 13 minus 2 root 2 root 2i, okay, plus, there you have plus 5 plus 4i. Now combine like terms. So there you have 13 and 5, which is 18, and you have here negative 2 root 2 plus 4i. So this, since you can't combine 2 root 2 and 4, you have to take as I in common. So anyways, this is going to be 18 minus 2 root 2i, okay, plus 4i. So this brings to the end that minus, okay, you can take 2 root 2 in common, I in common, so that would be minus 4 and I. So this will be the answer for the sum. Okay, so try the subtraction one, or let's move on to the subtraction one, the difference. So z1 minus z2, so you already have the two expressions or complex numbers, 13 minus 2 root 2i, okay, minus 5 plus 4i. Okay, so let's see what will happen. So first, distribute this negative for 5 and for 4. So 13 minus 2 root 2i. So when you distribute, that would be negative 5, negative 1 times negative times positive is negative 4i. So now just work on the real parts. All right, so that goes to 13 minus 5 is 8. So again, you have to take here negative 2 root 2i minus 4i. So this is going to be, let's take I in common. So you have here 2 root 2 plus 4. This will be the answer for the difference. Therefore, in general, if you are given two complex numbers z1 a plus bi and z2 c plus di, and then if you are asked to find the sum z1 plus z2, that would be the same as a plus c, okay, that is the real part, plus the imaginary part b plus d, okay, b plus d I. And then at the same time, if I ask to find the difference, all right, z1 minus z2, that goes to a minus c, okay, a minus c, that's the real part, plus b minus d, b minus d, the bracket I. So this will be in general to find the sum and difference of complex number.